Hello guys! Welcome to my video. And today, I will be discussing about the infrared thermometer. So what is an infrared thermometer? An infrared thermometer is a thermometer which infers temperature from a portion of the thermal radiation emitted by the object being measured. This thermometer is commonly used by medical professionals to measure body temperature. Before I explain how an infrared thermometer works, first I will discuss the basics of an infrared. An infrared is a type of energy that is emitted from the surface of all objects and is part of the electromagnetic spectrum that people encounter most in everyday life, although much of it goes unnoticed. This energy is invisible to human eyes, but people can feel it as heat. How does infrared radiation or IR thermometer work? In physics, heat is transferred from one body to another through conduction, convection, or radiation. In radiation, it is a process where heat energy in the form of electromagnetic waves is emitted by a hot object and absorbed by a colder object. Most of this radiation is in the infrared region of the electromagnetic spectrum, but some also spread into the visible light band. IR thermometry is based on the fact that any body, solid, liquid, or gas that has a temperature above absolute zero, which is a 0 degree Kelvin, emits radiant energy. This energy is proportional to the fourth power of the body temperature, and the body's ability to absorb and emit IR energy is called emissivity. So, how does an infrared thermometer work? The IR thermometer works by focusing the light that is coming from the object in the form of infrared rays and tunneling that light into a detector known as a thermopile. So, what's a thermopile? A thermopile is an electronic device that converts thermal energy into electrical energy. It is composed of several thermocouples connected usually in series or less commonly in parallel. Here's an example of a thermopile and its equivalent circuit. How does a thermopile work? Basically, it works on the principle of Seebeck effect. The Seebeck effect is a phenomenon in which a temperature difference between two dissimilar electrical conductors or semiconductors produce a voltage difference between the two substances. Here's what happens inside a thermopile. When heat radiation passes through the hot junction, a voltage difference is produced on the output. Here's a block diagram of a typical infrared thermometer. Normally, an IR thermometer consists of optical components, IR detector, an amplifier, a signal conditioning circuit, an analog to digital converter circuit, and a display or an interface output stage. So, what are the purposes of these parts? The optical component focuses the IR energy onto the detector, while the IR detector converts the IR energy into an electrical signal. Since all types of IR detectors produce signals in the microvolt range, a high gain amplifier should follow the detector. After amplification, a signal conditioning circuit should follow the amplifier. Basically, detector output versus temperature curves are not linear and fluctuate greatly with a change in ambient temperature. To remedy this, a signal conditioning circuit stabilizes the temperature and linearizes the signal. After linearization and temperature stabilization, Many applications require an ADC, which is an analog to digital converter, to convert the temperature reading to a digital format.
So in conclusion, why should I use an infrared thermometer? The main advantage of an infrared thermometer is that it can take measurements from a distance. Infrared thermometers are ideal for taking temperatures needed to be tested from a distance. They provide accurate temperatures without ever having to touch the object you're measuring. This is ideal when you can insert a probe into the item being measured. If the surface is out of reach, or if you have to keep your distance because of high heat. You might want to use an infrared thermometer to measure the objects that are fragile, dangerous, penetrable, susceptible to contamination, moving, or out of reach. Here's my demonstration on how to use an infrared thermometer. Basically, an IR thermometer has three buttons: the left button, center button, and the right button. The left button switches the thermometer from off to on. The center button switches the thermometer's mode from Celsius to Fahrenheit, or vice versa. So in reading the temperature, I will press the trigger, then press the left button. Then, it will basically display the temperature of the object being measured.